Oh, hello to this. What a nice start. Hello, welcome to this fifth and I suspect final video in this series where I've given you some tutorials on how to make Perlin terrain or procedural terrain using Perlin Noise. And this final video, I talked about how can we make our terrain a bit more interesting. And hopefully, what I'm showing you now is a bit more interesting compared to the previous terrain. Potentially you could make more realistic terrain and things. I make no claims that this is very realistic, but it's definitely more interesting. Oh, a little collision detection problem there. Right, so what have we got going on? First of all, we're using two different rock types. Also, I'm getting more detail in the rocks, so collision detection is terrible. And what else is going on? Oh, and we've got kind of like it is slightly more realistic, the terrain now, in terms of we've got like hills and valleys, and there are like individual, like independent details. We haven't just got these simple rolling hills and things like that. So how do we do that? Oh, we've got a sunrise. We've got an alien sunrise. Let's just watch it over the pink bioluminescent. I guess they're like crystals. There we go. Isn't that nice? Oh yeah, and we've got a. I think I had this sky on before. It's a procedural sky, which is fairly easy to make in Unity. Sorry, very easy to make in Unity, and a simple script where we're rotating the directional light, which gives the illusion of having a sun moving around. Anyway, if you'd like to know how to do that, let me know in the comments, and I'll write a tutorial. Right, so we've got more interesting terrain, and it's infinite. It's still infinite, and I've got it running. I made like a Google Cardboard app for Android. You can make it with iOS as well, and it ran at 60 frames per second. So our code is efficient enough to run in VR and be nice and satisfying. This is great, by the way, in VR. It's fantastic. Right, so how are we doing this? How are we making the terrain more interesting? Let's first look at a diagram. I'm a bit scared. Usually my diagrams don't go well. Okay, so what we did before, we had, oh no, this tool isn't doing what I thought it was going to do. Let's just go to a safer tool. I've not used this before. Streamer, no. Oh yeah, there we go. Pencil. I can't go wrong with a pencil. Okay, so we've got these tiles, and we had, that's doing that as well. What am I doing? Why is it drawing? Anyway, I can't use a simple program. So, is it the fill? Am I doing that wrong? Pattern, radial, noise. How do I take this off? There we go. Is that now? Ah, there we go. Now it's behaving like I thought it would. Okay, so we've got a bunch of tiles. Let's just refresh this. We have got some tiles like this, and then we make a grid of them, and then on each one we've got a little script that we called the hills are alive. And basically what happens is that script has got a function. I'm going to write an F. No, can't do an F. A function called generate Perlin Noise, I think it's called, something like that. And if another script calls that function, we could even write a little script where we press a button and it runs that function. It then gets all its vertices, which I'm going to represent with these like little dots. Well, that might be quite noisy in the video. Sorry, I won't actually tap too loud. So there was 121 vertices. Each vertex has got an X, Y, and a Z, and we're just like lifting up the Y component of that vector 3. And that gives us, I'm going to now draw a tile on its side. So we're kind of like looking along. Can I do some like 3D, look at this, 3D drawing. There we go. So we're kind of like looking along the tile, and then each vertex, let's say these are the invisible vertices. Oh, I'm doing the tapping again, sorry. There we go, silent tapping. So each one of them, then we're giving it like a random Y. Not a random Y, sorry, we're deciding the Y using Perlin Noise. and that depends on the coordinates of each individual vertex. It's going to be similar, its height, in terms of who its neighbours are, in terms of the coordinates of the world. And so that if we join them all together, we get some terrain that looks something like this. Okay, so we know how that works. And then terrain brain is the script. Let's do a little. So this is the terrain brain, and that script kind of coordinates the grid. It places all of the Perlin tiles, and it tells them when to generate, and also it keeps an eye on the player. I just do a PL in a circle for the player, so it communicates with the player's position. Once our player wanders a certain distance, I'll do a wiggly line. Once the player has wandered a certain distance, it then recenters the grid on the player, and then let's imagine this is the grid of Perlin tiles, recenters, and then it says to all of the grids, regenerate your Perlin noise, and they'll go and do so, and that gives us the illusion of infinite terrain. So what we want to do is to make this more interesting is not to apply just one Perlin function, but as many as we like. And the general idea, I want a slightly thicker pencil. Can I work out how to do it? Size, about there. And can I have blue? Am I allowed to go outline blue, please? Will this now work? So what you kind of want to do, this is too thick, but there we go, is apply your first lot of Perlin noise, which will look something like this. And then on the same Perlin tile, on the same terrain tile, let's get slightly thinner, you then want to apply a different amount of now what should we call this? It should be called the frequency. We've called it the height. Let's say height. You then want to say, okay, for each vertex, let's now bring you, say, up a little bit more, and for you over here, you'll go down a little bit, you'll go up a bit more. And so what we're kind of doing is adding like a finer resolution to the Perlin noise. And that underlying kind of shape of the mountains and things will be maintained, but we're just adding, say, a little bit more procedural variation. And then finally, you might go even one step more. Let's have a different color so we can kind of see it this time. We'll go some kind of pink. And then we add some more. So according to those little bumps, we then might add an even finer grain. And in programming circles, these are known as octaves. Have I got a writing tool? There we go. Perlin octaves. Octaves, like musical, like notation, where you go up 8 notes or something. That's one octave, and then another one. Because these heights can be. Where on earth is? I can't. I just want to move this around. I don't know how to do stuff. That one? Yes. Now I can move you over here. Perlin octaves. So each of these different kind of like waveforms is known as an octave, and the height is kind of its frequency, and then, or really its amplitude, sorry. Its height is its amplitude, and then the frequency is what we've called the gradient, so kind of how busy it is. And so the general idea is, yeah, you give it a nice like kind of rolling low frequency but great height, so big amplitude, very low gradient to begin with, to give like the general shape of the land, and then the next octave will kind of be the reverse, so, or a step down, so a lesser height, a lesser amplitude, and a lesser frequency. Sorry, a higher frequency. And then the tiniest one will have the highest frequency, so very spiky, but maybe you can only go up half a meter or something like that. Okay, but you can play around with those. You can do the opposite. I don't know. You can play around with them. So what I thought I would do, let's have a look at some code, or what I did. Let's make this a bit bigger. There we go. So we're in Terrain Brain. I created a vector 3 to hold that information. So the x component of this vector will be the amplitude or the height, the y component the gradient, and the z component the seed. You could also change the seed so that your kind of like bumps and things don't line up on each other, so you could have more interesting terrain, or you could keep the seed exactly the same and try out different things. Okay, so this vector called THGS is an array because in the diagram I've got 3 octaves. You could use, what if you wanted to use 15 and have something quite elaborate and quite delicious looking? You would need, well, you don't know how many you're going to need, so an array is what you use when you want to have lots of things, you're not sure how many you're going to go for. I think I've turned out to use 3. And let's have a look at that, sorry, in Unity. So if I go to Terrain Manager, which is simply an empty game object, it's got a transform and this terrain brain, and that's it. Because I've made it public, we can control this terrain height, gradient, and seed, or amplitude, frequency, seed, like component property from the outside. And then we can, what Unity allows you to do, once you've made an array public, you can manually put in how many objects you want in that array, and then you can fill in your height, your gradient, and your seed manually. So what I've done is ask for a height of 222. That's our gradient. Generally needs to be bigger than the amplitude, than the height, to have like rolling smooth hills and things. And then I've done as I explained before. So I've gone the height gets less and less, and so does the gradient. And so the final little gradient is very, very small compared to the height, and that gives a nice spiky effect. So let's just have a look at that terrain working. So that's working on the main areas, the blue. So those spikes are determined by that final object. So what I'm going to do, what if I swapped that and said you can go up a height of 3, but your gradient is 15. We should now have like a smoother finish. We should. Let's have a look. Yeah, so a much smoother finish. And if that's the look you're going for, so be it. There we go. You know what? That's quite nice and smooth. That would be nice to drive around, I was just thinking. I'm tempted now. Let me just show you. Should we have a look at our car? So I'm just going to disable the egg bod and go for a car. And remember that in our terrain brains, we've got to tell them what our player name is so that they can center the terrain on the correct thing. So I've just changed it to the player's new name. I can't remember if I've got the camera set up. Yes, I have. So here's our new egg vehicle. It's very important. I thought it would do well with this smoother terrain. I'm still terrible at driving. So I've got like a free camera on the back so I can have a look around. And then I can control the egg car. I thought I'd just have a look at that. Right, I'll use the egg car to talk about the neon pink. So can you guess how I've added these rocks? These pink rocks are controlled by the same procedural algorithms as the rest of the terrain. And you probably guessed, all we have to do is introduce a new game object, empty game object, attach the terrain brain script to it, and then choose a different Perlin tile as our prefab. So let me just show you that now. So this is the first terrain manager, and the prefab is the little ground, and that's the first terrain that we kind of made. And all that's got on it is the Hills Are Alive script that generates the terrain that we did in the first video. But then I've made another prefab, and I've just made sure it's like bright pink and it's emissive, the material, so it glows in the dark, and it's just got the hills are alive again. So it can be used by any of these guys, these terrain managers that you wish. So all I've done, I've named it Terrain Manager Pink Rocks, and I've dragged this new prefab into our public space here. And then I've only got one element in the terrain Perlin Noise function. So I've just said the spikes can be 111 high, or the amplitude can be 111, and a very small gradient, so I wanted it quite spiky, and I've just put the seed as 1. There you go. That's how to do that. I'm just going to switch these values back while I remember. Okay, so how do we actually apply 3 lots or an array of Perlin Noise functions in the code? Let me show you. So this is in Terrain Brain. First of all, just a reminder, we declare our public vector3 square brackets after it to make sure that it's an array. And in the hills are alive, so this is a script controlling each individual tile, we then need an equivalent. So I've just written public vector, or copied and pasted public vector 3 square brackets THGS. There we go. So the same thing. Basically what's going to happen is in the loop, or in the function where we relay our tiles, if you remember from the previous videos. Well, let's go, no, sorry, not in relay your tiles, in, where's lay terrain? We only need to apply these values the first time we kind of lay out the terrain. So remember, in layout terrain, our prefabs get instantiated. So our grid of terrain is first made. And what we do then, first of all, very importantly, where is it? Where is it? There we go. We get hold of each terrain tile in the for loop, and we make sure that each tile's vector 3 that holds the height, the gradient, and the seed, the THGS, equals a new vector in brackets THGS length. So this is the variable, the vector 3 variable that belongs to the terrain brain, and that dot length just holds how many Perlin properties. We have 3 that you've got attached to the script, and it applies that number, or it makes sure that each individual tile has got that same number. So that's the first important thing to do. Okay, it's very similar to, remember when we made our tiles? Before we can put Perlin tiles, the prefabs, into this array, we have to tell that array how big it's going to be. So in this instance, we did the X tiles times the Z tiles to give the number of tiles in the whole grid. So we're doing a very similar thing, but it just so happens that this array belongs to another script. That's why we're using the get component. Hills are alive. Okay, so then we're just basically running a little for loop where we're iterating over our elements in this array, and we just copy over the value that we've written in this script in here in the public area. We copy that over or apply that to the scripts. So get component the hills are alive. So get hold of that script, find the THGS, index the element or object in that array, and then set .x, .y, .z. Sorry, I didn't articulate that very well, but you can probably see it in the code nice and clearly. Right. Okay, so we're basically just copying the terrain attributes as controlled and organized by the terrain brain, and copying those in the code behind the scenes onto our prefab, onto our, sorry, instantiated prefab. Okay, and that just happens in our layout terrain. We don't need to do that again. Once those values are set, the terrain tile, the terrain brain knows what to do, uses those values forever. So let's just have a look at that. That's a little complicated. So we'll go to generate Perlin hills. So this is the function that's called when the terrain tiles are first laid out, and then whenever the terrain brain relays the grid centered on the subject, this function gets called. And what we do, we're looping around all the vertices, 121 vertices on that plane, and then we apply, where is it? We apply the height, gradient, and seed. And what we're doing, we've nested a for loop. So we've got an internal for loop here, where we apply the Perlin noise, and we've kept all of this code the same in terms of, you see the gradient variable appears here. Where's seed? Seed appears here. We've got height appears over here. And just before we're applying those, we just say the height equals terrain height, gradient seed, point x. So x means the height, the gradient equals the y component, the seed equals the z component of its own THGS indexed vector. Sorry, I said that in a complicated way. So basically, we're just looping through, in this case, 3 times, because our terrain brain had 3 elements in its array. So this will run and apply the Perlin noise 3 times. So we're doing what we explained here. So first it applies the smooth, large hills, and then the slightly spiky ones, and then the really spiky little ones. And you could have, say, 100 of those going through, and this little for loop will go around 100 times, dictated by the length of that array. That's ultimately controlled by the terrain brain. So another so that's the most complicated thing. So I haven't done that from scratch. I apologize if you like to do it from scratch. Hopefully that was helpful. You could either have a go at doing that yourself now you know the principle, or copy and paste my code. Absolutely fine to do that. But there you have the principle. How to make more realistic or more interesting terrain, and there's one method of doing it with an array. You could hard code it and just always have 3, and then you could have like a Perlin 1, Perlin 2, Perlin 3, or use an array. Designing this array was a little trickier, but now we have a very easy functionality. So what I want to show you is, if I click on this prefabbed Perlin tile, I've got the Hills Are Alive script. You'll notice that you can no longer see the Perlin noise attributes and things like that. I've made sure they're hidden, and to hide them in the inspector, you simply write in brackets hide in inspector, and then you can keep these variables as public, and we need them as public so that our terrain brain can access them. If they were private, not public variables, this script wouldn't be able to say get component, the hills are alive, and then grab the variable it needs. The variable needs to be public on this script for other scripts to get hold of them. So that's what that word means. Public. It's kind of publicly available to other scripts in their little computer world. So there we go. So hide in inspector is if we don't want a user to think, oh, I can control the Perlin noise from here, when really the terrain brain is doing all of the work, and the user would waste their time. Okay, so that's how that's working. I've made a few other changes. The last change I'll just show you, and then we'll finish the video. I'm sorry, I didn't really do any coding. I'm just kind of showing you how it works. But one easy change, when we apply the Perlin noise, what we're doing originally is just raising each vertex using the y component of that vector. What I thought of doing was just timesing by the height still, but before we raise it, we lower it by half the height, and then we have a chance of raising it from that point back to 0 or going beyond that. So that just means that we can now, if the number that we're getting back from the Perlin noise function is kind of like low enough, then the terrain can now dip and go up, or go up and dip properly, but below the base level. So you get some like more like valley kind of things going on. So to do that, you simply do plus equals minus the height plus the Perlin noise usual times the height. So really, I've just added that to the beginning of the function. Also, just to get this to work, where is it? I'm sure I'd have to zero the y component. Oh, there it is. Yeah, to get this to work. Beforehand, we were simply saying each vertex's y equals math f Perlin noise. So it equals whatever number we get out of here. What I'm doing now is just making sure every time we generate the terrain, all the vertices go down to 0, and then we plus equals the result of the Perlin noise function. We do plus equals because we want to kind of accumulate that Perlin noise, because we've got an array of Perlin noise properties going over it. So that had to change because of this new dynamic way of, or more interesting way of using the Perlin noise. So zero the y component first, the y value first, and then plus equals accumulate the various Perlin properties. Okay, that's all there really was to that. So I think we'll finish with just me driving around to show you this after we've talked about it. So there we go. So you can see now oh yeah, I'm not going to be able to handle the spiky kind of terrain anymore. Okay, in the new fashioned, I hope you like the new egg vehicle. So we've got, yeah, I love being able to see into the distance. It's fantastic knowing that you can walk on forever. I love infinite procedural terrain. Oh yeah, another final tip then, just looking at our glowing pink rocks. You can have as many like different rocks as you like and things, or different, what should we call them, like terrain objects themselves, terrain brain objects. I found it's kind of best to have one of them lower than the other, so it kind of sticks out, and then you won't get any like unsightly terrain like ending is not really matching with the other one. And make sure that the terrain tile itself is the same size, are the same size, equivalent sizes, and that maybe you've got the same number of terrain tiles in your grid, and then everything will line up. Let's just see if I'm true to that. So my pink rocks are 12 by 12, so that's quite large. And actually, I've made these ones smaller, so the main terrain, the grey rocks, are 6 by 6. The smaller you go, the kind of better resolution you get, better results you get, a better look. But it costs because I've got 44 tiles in that grid and only 12 for the pink rock. So if they're smaller, you kind of have to have more in your grid to look further into the distance. And once you get like a number like 44 tiles and things, it will slow down performance. On this MacBook Air, it seems to be fine. I did for the VR, I had to reduce that number as much as possible and fiddle around with this array and things to make sure the performance was okay. You want it to run silky smooth if you're in VR, to make it a really nice, pleasurable experience. I was just going to say one thing. What was the last thing? Maybe that was it. Oh yes. You may notice in the code, I won't explain this, but I tried out some different methods of having infinite terrain. So in Terrain Brain, I've got relay smart terrain. So I had an idea of, instead of trying to like move all of the terrain around the player, I just thought of maybe just peeling off one tile per frame, which isn't computationally heavy and would be smoother. And it kind of worked, but it took too long and it was leaving gaps in the terrain that you could perceive around you. And then I tried a much more radical one called Paint On, and all I do here is calculate which is the furthest tile away from the player with the find yonder function, and then I paint that tile in front of the player. So every time the player kind of like rotates a little bit or walks, I think the distance of a single tile, it will grab just one tile and put it ahead of the player, and you can switch that on with a ball. So I'll just show you that working. Let's do it for everything. So if I click this, painting terrain, and pink rocks painting terrain, it runs a lot faster in terms of that big jolt. The big jolt being when we need new terrain generated, it has to do all of the terrain. So there's a little like judder, you'll notice. But now, you'll see it doesn't quite paint it in the correct position, and you get a strange effect. I don't know if you can see that. Let me get out of my car and go back in this other player mover thing, and we just have to tell our terrain brains what the player is called. Okay, so now if we play, I should be able to move a little faster, and we can see this paint on technique a little more clearly. Okay, let's see if I can get to the edge of the map. So you can see the terrain is being painted as I move around, which gives a very different feel and a kind of immediate evidence of Perlin noise and procedural terrain kind of happening. There we go. So we've got right to the edge of the terrain, and now it will just paste it wherever we kind of walk. And if we look back, we've got kind of this path leading off. So it doesn't look as realistic, although this is quite a nice effect. It kind of, I haven't tried it in VR yet. It would be really cool, I imagine, to kind of like look around and be able to kind of like paint the world in front of you as you walk. That might be a nice game or simulation or art mechanic. Ooh, that's quite exciting. Yeah, so we look around and it paints the terrain wherever we're kind of like looking. Okay, but not as satisfying. So I'm just thinking there might be a way to kind of combine these different techniques and organize them so that we get the maximum efficiency with the best and most beautiful kind of look. Oh yeah, so absolute final word. This is my final word. You'll notice sometimes, and if you experiment with this code, the tiles don't quite line up on one another, particularly if you get bigger and bigger prefabs. And that's because when we center the terrain on the player, the individual vertices won't be kind of in the same kind of aligned. That's the word I'm looking for. Won't be aligned. So if we say had a terrain tile here and our player moved up here, and then we have say the back edge of the terrain now there, it won't line up exactly where the old tile was. Something the vertex will be slightly different, and so you'll get uneven or a change in where the terrain was, which can kind of spoil the effect. So an improvement that I need to do is when we kind of center the player or build our grid, we should build to like a prefixed grid locations, and when we shift, we're always shifting by kind of a fixed snap to grid amount, and then the vertices will behave and everything will line up absolutely smoothly and beautifully. Right, there we go. I hope some of that was useful, and I'm sorry that I didn't code from scratch in front of you. Any suggestions or any requests, leave them in the comments and I'll try to help you out. Right. Thank you very much. Have a lovely evening. Goodbye. Oh, this is the end. This is the end of our terrain. Goodbye.